We're going to move a step ahead in our study of decimals, our new math strand study right now. Hopefully you watched the introductory video. If not, I recommend going back and watching that, because in that video I talk about what decimals are, where they come from, why we even need them. Because I don't like to teach something that students really don't even know what it's about or what it means. So please review that video. We're going to take it to the next level in this video. We're going to talk about place value, and we're going to include decimals. I've done a prior video on place value, so if place value sounds foreign to you, go back and look up a video called base 10 or place value. I think both names are in the title of the video, and we'll link it in the description of this video, so you can go back and review that real quick and then come back to this one, because it gives you the basis of what happens to the left of the decimal, where the decimal represents all increasingly larger whole numbers. And then to the right of the decimal, to the right of the decimal is where we're going to enter our decimal or our parts of those values with the place value system. So it's good to be a good review to recall what that is. So let's dive into that, and I'll review it real quick here too. If I put a number in this place, this is called the units place, or the 1. What that means is this number is worth its value, or it's times 1. So 2 times 1 we know is 2. So any number there is literally worth 1, 2, what it counts to, its whole number value. Remember, the base 10 system, though, is built with 10 digits only, 0 through 9. You'll see that in the base 10 video. And then the place value system is what helps us to build larger and larger numbers, because now I need numbers larger than 2. So let's put a number in this place, 3. This place is the tens place. So any digit in this place is worth 10 times what its original value is. So this 3 is worth 3 times 10, or its actual value is 30, which helps us build the number 32. 30 plus 2 is 32. And then I can go higher. I need to build numbers that are higher. So a digit in this place, which is the hundreds place, is worth 100 times that. And these things by now are probably second nature for most of you, but it's good to review the construct of the base 10 system, because we can start to take it for granted. And that's when something like a decimal, becomes confusing. So this is worth 4 times 100, or 400. And then we're going to go up to the thousands and stop for this discussion. So any digit in this place is worth 1,000 times what I put there. So if I put a 5 there, it's actually worth 5 times 1,000, or 5,000, which of course is how we get the number 5,430. 3 times 10, 2. Now we need to communicate parts of numbers, as we see in money. Almost everything you buy ends up being a part of a number. It's very rare you walk into a store and you're charged a whole number amount for anything. So decimals are just part of your life. And we're going to build this out to 2 decimal places, because that's the most common. In sciences and maths, and in study of science and math, you go much further than that eventually. But for today, this will work for us. So everything on to the left is times 10. So each time I go up a place value, it's 10 times the last one. So 1 times 10 gets us to tens. 10 times 10 gets us to hundreds. 100 times 10 gets us to thousands, and that's the way it works. So going the other way, I'm dividing by 10. So when we put the decimal in, we're saying we're done with the whole numbers. We're going to get into parts of numbers. So continuing this pattern, if we divide by 10, now we're at 1/10, or 1 divided by 10 for this number. So any digit that I put in this place, say I put a 3, it's worth 3 divided by 10. It's not even worth a whole anymore. It's less than 1, because we recognize 3/10 as being less than 1, because you probably worked with fractions. So this place value it's called the tenths, and it's literally worth 1 divided by 10. So 3 over 10. The next place, I divide by 10 again, I get 1 divided by 100, and so it's a hundredths. So this place is named the hundredths. Literally means 1 divided by 100. So any digit I put here, I divide by 100 to get its true value. So if I divide by 10, I got a number smaller than 1. If I divide by 100, then you can imagine I got a number much smaller than 1. So as I continue to the right here, the numbers get increasingly smaller. I continue to the left, they get increasingly larger. Continue to the right, they get increasingly smaller. That's the way the system works. So we're going to stop here, and this can be built out in either direction as far as we want to go with it. We're going to have you do a little bit of practice, and the practice is going to look like this. We're going to skip the ones in front because hopefully you remember those, and we're going to deal with the decimals. So we're going to put a number just like this one up for you, 5,432 and 35/100ths is how you would say that. We're not too worried about how you say it, just that you know the value of the digits. And we're going to ask a question, what is the value of the 3? Or what is the true value of this 3? There's 2 3s, so I'm talking about this 3. And you're going to respond, it's worth 3 times 1/10 or 3/10. So that's going to be your answer. So we're just going to practice that, increasingly, dividing by an increasingly smaller number. And so I'm probably going to ask you too, what is the value of the 5? And I'm talking about this 5. We won't put more than one of the same digit in here so you don't get confused. So what is the value of the 5 in that number? And you're going to respond, it's in the hundredths place. And we'll have a place value chart for you to look at. We don't expect you to memorize that. So your response is going to be 5 times 1/100 or 5 hundredths. And that's going to be as simple as that. So have you do a real quick practice set on that, and then we'll move on to the next step.